Welcome to the Podkey summary of Debug and Profile Agentic App Experiences with Instruments from WWDC 2026. Today's thread is basically this. Building with language models looks simple, right? Up until you need it to be reliable. The big themes are testing outputs that won't come out the same way twice, figuring out what broke when several models are chained together, and using Apple's Foundation Models instrument to actually see what's happening under the hood. There's also a very real lesson here about tiny configuration mistakes, because one missing tool left an app politely spinning its wheels with no obvious error at all. One of the first mindset shifts with LLM apps is that responses are probabilistic. You can send the exact same prompt twice and get two different answers. Both may be reasonable, which means the usual unit test habit of checking for an exact string match starts to fall apart pretty fast. So developers have to test for intent, quality, and whether the response is doing the right kind of work, instead of pretending the model is a deterministic function. That sounds subtle, but it changes the whole testing paradigm. It gets trickier when one model hands work to another. If you've got an app that first identifies ingredients and then passes that list into a recipe generator, the handoff itself becomes part of the system you have to trust. Now the problem isn't just whether each model works on its own. It's whether data flows cleanly between them, and whether the app can recover when a downstream model stumbles. That kind of graceful recovery becomes architecture, not a nice extra. This is where observability stops being a buzzword and starts being oxygen. In a multi-model pipeline, if something breaks and you can't see what each model received, what it decided, or why it failed, you're basically debugging through fog. The foundation models, Instrument is meant to clear that up with a hierarchy of sessions, then requests, then inferences, then prompts. That structure gives developers per-step visibility, which is exactly the missing piece in these workflows. A nice detail here is the tree view. Instead of a flat timeline where everything blurs together, you can click down through each logged event and inspect prompts, responses, duration, and token metrics at every level. That drilling down turned out to matter, because the timeline alone didn't reveal the real issue. Once the presenter explored the tree, it became clear that only one instruction set was active and the available toolset was incomplete. Dynamic instructions is powerful, because it reevaluates before every request. That means the app can swap in context-specific instructions and toolsets as the conversation changes, which is exactly the kind of flexibility people want in agentic systems. But it also creates a sneaky failure mode. The instruction set can silently stay unchanged. In the demo, the app was supposed to move from brainstorming into tutorial mode, but the switch to tutorial mode tool was missing from the instruction set. So the app just stayed in brainstorming mode. And from the user's point of view, it looked responsive enough to be convincing. That's what makes this bug class so annoying. The app kept accepting input and making tool calls, so nothing crashed, nothing screamed, and there wasn't a dramatic red error banner begging for attention. It just looped politely in the wrong behavior. Without deep tracing, that kind of silent configuration failure is hard to spot, because the system appears alive while the user experience is going nowhere. Adding the missing switch to tutorial mode tool to brainstorm dynamic instructions fixed the transition, which confirmed the issue was tiny, specific, and easy to miss. Beyond correctness, the instrument also exposes 3 performance metrics for each inference: time to first token, tokens per second, and total latency. These are useful because they map pretty directly to how the app feels. A high time to first token means the user is staring at a blank screen wondering if anything is happening. Low tokens per second makes generation feel sluggish once it starts. And high total latency just stretches the whole wait, which is never a crowd pleaser. A couple of the optimization ideas are refreshingly concrete. Shorter prompts can reduce time to first token, because there's simply less for the model to chew through before it starts responding. Streaming partial results can soften perceived total latency, since users see progress instead of silence. And benchmarking tokens per second is a good way to catch regressions after prompt edits or model swaps. which is one of those habits that sounds boring until it saves you from shipping a slower app. There's also an evaluations framework in the mix, and that pushes this beyond debugging into improvement. The idea is to measure prompt effectiveness using structured evaluation data, then connect those results back to the instrument traces. That creates a feedback loop where a quality problem isn't just a vague feeling that the model got weird. You can tie it to concrete trace data, latency, or token usage patterns, and work from there. One practical note: the Foundation Models instrument works with any model integrated through the Foundation Models framework, not only Apple-provided ones. That broad compatibility matters because most real apps are not living in a one-model, one-vendor world. Developers do need Xcode 27 and the latest OS on the profiling device, but once that's in place, the tool gives a uniform view across supported LLM backends. The through line in all of this is that LLM apps don't just need prompts, they need testing, tracing, and a way to see subtle failures before users do. And sometimes the whole mystery comes down to one missing tool in one instruction set, which is both humbling and very software. This episode was generated by Podkey. Create your own at podkey.fm.